Welcome to Digital Learning Day 3, guys. In this video, I'm going to go over solutions to 4 of the problems that are in your worksheet, homework assignment that's being given to you today. You do not have to watch this video to complete the homework, which the homework itself is going to be used to mark whether or not you're absent or present for Digital Learning Day 3. So if you would like to see how a few of these problems work out from the worksheet, you're welcome to stick around for the video. But if you feel confident that you can do these problems, you are welcome to tackle the problems on your own. So, without further ado, let's go ahead and get started here with problem number 1. The numbering here in the notes 1, 2, 3, and 4 doesn't necessarily match up with the numbering of the problems that I'm pulling these from on your worksheet. So, problem number 4 here in the notes that we're looking at together is not the same as problem number 4 on the homework. It's towards the bottom. Hopefully there's no confusion there, though. All right, so let's go ahead and simplify 30r squared minus 36r over 18r squared plus 60r. This is a rational expression, two-word term meaning rational, referring to the fraction that we've got here. And an expression because we've got variables, just like an algebraic expression has variables. All right, so when we simplify a rational expression, we're looking to see if we can factor any of the numerators or denominators here. Looking at this 30r squared minus 36r, we know that can factor. We've got a GCF that is bigger than 1. So let's write this out. We've got 30r squared minus 36r. GCF, look at first at the 30 and the negative 36. What's the biggest number that divides into both of those? Well, 6. And we have a common r to both of those terms. So pulling out the 6r in front, we are left with the following. We have 5r minus 6. All right, so we'll circle this. That's important stuff. We're going to come back to that in just a second. All right, so we factored the numerator. Looks too like the denominator can factor. At the very least, we're noticing 18 and 60 are both even numbers, so that'll factor a little bit. All right, so factoring the second piece here, we had 18r squared plus 60r. Look for the GCF. 18 and 60 are the biggest number that divides into both of those is going to be 6. And again, we've got a common r to both terms, so we're pulling out a 6r in front, leaving us with a 3 and an r for the first term and just a 10 for the second term. All right, circling that as well. That's important stuff to help us simplify the rational expression up top. All right, so now that we've factored both the numerator and denominator, let's go to the color blue. We're getting closer to our answer here. We're almost there. We're going to rewrite the numerator and denominator as follows. 6r times 5r minus 6 all over. The denominator factored is 6r times 3r plus 10 times 3r plus 10. Look for factors that are going to cancel from both the numerator and the denominator. And that's not too hard to see, that the 6r's cancel out of both, leaving us with a 5r minus 6, a factor that is not in common with the 3r plus 10 in the denominator. So here you have your fully simplified rational expression in blue. Box for you. All right, not too bad. Second problem we're looking at, again, don't pay too much attention to the number in the notes here. It's not necessarily going to match up with the problem number in the homework assignment. But this is coming from the homework assignment. So we've got k squared plus 5k minus 14 all over a large trinomial being divided by 1 over 5k plus 2. All right, first thing that you should remember when you are simplifying the division of rational expressions is that you need to keep it, change it, flip it, just like you would have done back in middle school if you saw the problem 4 over 7 all divided by 3 over 7. You would keep the 4 over 7, you would change the division to multiplication, and you'd flip that second fraction to 7/3, giving you 28 over 21, which reduces to 4 over 3. Same idea here. So this was just kind of an aside. That's not going to help us with this problem per se, but just to jog your memory as to how this works. All right, so we're going to rewrite this in red as k squared plus 5k minus 14 all over 5k squared plus 52k plus 20 times, we're changing to multiplication here, 5k plus 2 all over 1. All right, piece by piece, let's go through and see which of these numerators and denominators can be factored so we can simplify this guy out. Well, we know, looking at the second denominator here, I'm going to box this up. That's not factorable. That's a single term. It's got nothing because there are no other terms in that denominator, there's nothing that we can pull out that it would be in common with, because it's just a single term. 5k plus 2, also not factorable. Notice that 5 and 2 have a GCF of 1. There are no k's in common. And because you don't have a k squared term, you can't factor by grouping. You can't use, if you're in my class, the rainbow bridge method thing. All right, so let's go ahead and take a look at this k squared plus 5k minus 14. It too, because you've got a 1 in front of the k squared, 1, 5, and 14, negative 14 in this case, have a GCF of 1. There's no k in common, but you can factor by grouping. So we'll come down here, we'll write 1k squared plus 5k minus 14. Again, we said the GCF is 1, so that doesn't take us anywhere. Instead, we'll multiply the coefficients of the first and last term. 1 times negative 14 is negative 14. We're looking for factor pairs of negative 14 that add up to 5. Those are going to be 7 and negative 2. 7 times negative 2 multiplies to give you negative 14. 7 plus negative 2 adds to give you 5. So let's use these two terms right here, or those two numbers right there, to separate the middle term of this trinomial. You're going to have 1k squared plus 7k minus 2k minus 14. We will group and look for things that are in common to each group here. 1k squared and 7k has a k in common, so pulling that k out, we are left with k plus 7. Negative 2k minus 14 has a negative 2 in common. Pulling that negative 2 out, we are left with k plus 7. So, finishing this factoring by grouping up, we've got a k plus 7 out in front of a k minus 2. And again, we're circling this because that's going to be valuable to us when we rewrite this fraction times a fraction problem with all the factored pieces that we can. All right, so we've boxed everything that we factored so far. Let's go ahead and see if we can factor this last guy here, the first denominator of the first fraction, the only denominator of that first fraction. We've got 5k squared plus 52k plus 20. Look for a GCF here. In this case, 5, 52, and 20 don't have a GCF other than 1, and we don't have a k term, or the variable k in all three of these terms. So the GCF is just 1. That didn't help us out. Let's factor by grouping and see if we can get this simpler. 5 times 20 is 100. We're looking for factor pairs of 100 that add up to 52. And I think 2 times 50 multiplies to give us 100. 2 plus 50 adds up to that 52 we need in the middle term. So we found our factor pairs. We're going to separate this as 5k squared plus 2k plus 50k plus 20. Group. From the first set of parentheses we can pull out a k, leaving us with 5k plus 2. From the second set of parentheses, I see a 10 there. We've got a 50 and a 20. So we'll pull out a positive 10 in front, leaving us with 5k plus 2. All right, great. We're seeing the same thing in each set of parentheses 2 times here. So out in front, we've got a 5k plus 2 multiplied by a k plus 10. All right, we factored that guy. We're circling it that we also need that when we rewrite that first fraction here. So in blue, we're getting close to our answer. The first numerator here we're going to rewrite as k plus 7 times k minus 2. The first denominator we're going to rewrite as the factored version, 5k plus 2 times k plus 10. I think that was k plus 10. Let me double check. Yeah, k plus 10. All right, times 5k plus 2 in the second fraction, all over a lonely 1. All right, so let's go ahead and see if we can find the factors that are common to the numerator and denominator here. I see a 5k plus 2 that cancels from top and on bottom. And that's it. I don't see anything else that cancels out. We've got a k plus 7, a k minus 2, and a k plus 10 that are unique. So, final answer of k plus 7 times k minus 2 all over k plus 10. And you're welcome to leave your answer factored like that. You do not have to distribute. You don't have to FOIL that numerator back out. All right, so we've tackled 2. Third one here is pretty quick. We've got a 3 over 6a plus 30. Adding to that, we're adding two rational expressions, a plus 2 over 6a plus 30. All right, we are going to first notice that we've got common denominators here. So look to the common terms or like terms, excuse me, in the numerators here. We've got an A. I'll put a box around that, just like going back to elementary school. You're trying to match the shape with the right peg here. So we've got A's. We'll circle the 2 and the 3. Just the number terms there are going to be able to combine. So numerator, when we combine these two fractions, we'll have a single A. 3 and 2 gives us 5. This is all over 6A plus 30. Remember, when you add or subtract rational expressions, just like if you had 3/7 plus 4/7, you are not combining the denominators there. Because you got a common denominator, you can combine the fractions, but you just say that'd be 7 over 7 or 1. Notice you only change the numerator. All right, so getting back to the problem at hand, we have combined where we could, but I think that we can simplify this even further because the 6A plus 30 right here factors. The A plus 5 does not. A plus 5 has a GCF of 1, and we don't have an A squared term, so we can't factor by grouping. But 6A plus 30, pull out the GCF here of 6, then you're left with an A plus 5. All right, we'll circle that. Let's come back up here and rewrite what we thought our final answer may have been. We've got an A plus 5 up top. That hasn't changed now. In the denominator, we've got 6 times A plus 5. Notice the common factors of A plus 5 top and bottom. If I cancel out the A plus 5 up top, there's still a 1 that's left. Anything that I have in the numerator or denominator is always multiplied by a 1. So this is 1 over 6 for a final answer. All right. And there you go. That simplified really nicely. All right, last one here. We are going to divide polynomials here. You've got a trinomial, 10x squared minus 80x plus 66, being divided by a binomial, x minus 7. Let's write this out just like we would have in elementary or middle school to do division with numbers, only we've got some variables thrown into the mix. So we're going to say this is 10x squared minus 80x plus 66. That's the dividend. It goes underneath the fraction sign here. And the divisor, the thing that's doing the dividing here, is x minus 7. All right. Piece by piece, you're comparing. I'm going to underline things here. You're comparing, let's underline in green. You're comparing the first term of the divisor to the first term that you're dealing with in the dividend here. So you're asking yourself, how many times does x outside the division sign here go into 10x squared? Well, divide this out. Notice that you've got a common x on top and on bottom. X goes into 10x squared 10x times. So I'm going to write that 10x, that's useful. We're going to write that right over the negative 80x. We're going to line everything up that has similar power here. 10x has a power of 1 just like negative 80x has a power of 1. All right, so let's go ahead and multiply this 10x times the x. So 10x times x is a 10x squared. Actually, let me change a couple of my colors here. And blue is what we need for our final answer. And red is going to be mainly the mechanics of us solving this out. So 10x times x gives us 10x squared. But you've also got a negative 7 here. 10x times negative 7 gives you negative 70x. All right, so just like when we did division, long division back in elementary and middle school, we're going to draw a line underneath and we're going to combine where we can. But remember, we're subtracting all of this off right here. So the sign of that second line, because we're subtracting all of that off, we're changing the signs to negative 10x squared and positive 70x. Now let's combine. Let's just add the coefficients in front. 10x squared minus 10x squared, those cancel out. Negative 80x plus 70x, combine the negative 80 and 70, you're left with negative 10x. All right, well we've got, notice that over here, you've got two terms in the divisor, and the negative 10x that we just wrote is only a single term. So just like you did for long division from the past, you're going to bring down the next thing that you see, the plus 66 here. And we're going to now ask ourselves, compare the x to the negative, didn't even grab the blue. Compare the x to the negative 10x here. How many times does x go into negative 10x? Well, divide out that x that's common to top and bottom. We see it goes in negative 10 times. So stacking, keeping track of the place here, negative 10 has a power on the x. There is no x term, just like 66 has no x term. So we're going to stack this negative 10 right above the 66, multiply that negative 10 times the x, giving you negative 10x. That's a good thing. We're saying the same thing twice. Negative 10 times negative 7 is positive 70. All right, just like above, we're subtracting off that second line. So we're changing the sign to addition and subtraction here. Negative 10x, positive 10x, those cancel out. 66 minus 70 gives us a negative 4. All right, so like you may have remembered from elementary school, we could write this as 10x minus 10 with the remainder of negative 4 that we couldn't deal with. Notice we got a remainder of negative 4 because there was nothing else to drop down over here. Nothing else. We ran out of terms to use. But that's not how we're going to do it in this class. Instead of saying remainder of negative 4, it's really best to say that we have 10x, and this is how I would like you to do this on the homework assignment, 10x minus 10 plus negative 4 divided through by x minus 7. That's the fraction that we were left with. And here, boxed in blue, is how you would write your final answer. All right, that's your notes for those who are looking for them. Hope you do well with the Digital Learning Day homework, and I'll see you next time.